In this video we're going to look at the internet, servers and routing in computer science. So the internet is a massive group of networks that allow traffic to pass through the network even if the destination is not their network. Okay, so we've spoke about local area networks, wide area networks. The internet is essentially a massive network of lots of different networks, and your internet service provider, your ISP, is one of those networks. Now, there's many applications that can be and are run on the internet. For example, downloading things, emails, VoIP, streaming, but the World Wide Web, websites, go on YouTube or whatever it is, that's just one of these things, one of these applications. The internet contains loads of different servers that do loads of different things as well. Okay, so it's not just Google. So if you put in an example question, the internet is Google or the internet is World Wide Web, you're not correct. So an internet service provider or an ISP. So internet service providers are companies that provide access to the internet for a fee. Essentially, you connect to their network, which then connects you to other networks. Now, some ISPs themselves rent their network space from larger companies, and all ISPs have some sort of rules that you need to follow, such as a data cap. So what I mean by the second bullet point is, especially where I'm from, there's one major ISP. However, other companies, smaller companies, provide different services. For example, instead of just your regular broadband or fibre optic broadband, some companies do what's called a beamed network. That is where you have like a little satellite dish or a little dish on top of your roof essentially, and you can get internet through that way. And that is used for people who live in the countryside or where the internet's not very good, and these smaller companies try and improve the service. But again, they'll just be hiring their network space from somebody else. Now, an IP address is a special 8-bit number that essentially like your house address. So when a device connects to the internet and within internal LANs, it is given an IP address, an internet protocol address. Now, this IP address uniquely identifies a device for as long as the device is on the network. Now, the addresses are used to send traffic back and forth all over the internet. Now, you see I've got an example of 192.0.1.1. That's an example of an IP address. Now, if you type that into your router, so into your net browser, what that should do is connect you to your router. I mixed up about a second ago. Now, what that will do is that will allow you to access your router, and you can, if you know the password, you can log in and change things and add passwords and things like that. So you can get 4, 8 and 32-bit long IP addresses. Now, if you want to know your own IP, if you just type in my IP into a search engine or go onto something like whatsmyip.com, you will get a number popping up on your screen which shows your IP address. Now, obviously, if you use a VPN service, a virtual private network, that essentially gives you an alternative IP address because you're going through somebody else's network. And then that's why some people can pretend they're from England when they're in China and things like that. And it allows you to get around certain blocks. Now, routers are devices that are used to forward traffic between different networks. Routers look at packets, which we're going to talk about later, and determine the best network to forward traffic depending on the traffic's destination. Now, the route it decides is based on lots of factors, including its understanding of the network at that point. So usually what we say is that a router picks the fastest route to get to its destination. So say there's a particular route that's got lots of internet traffic, it may avoid that network. So because it might take even longer to go the fastest route, but there's too many people on there. So I like to think of it a little bit like a road. There's many different roads in a city, and you can take multiple different routes to get to one place. Now, if there's loads of traffic, because you're going down a main road, then it might be easier to go through the back streets. It's a little bit like that. So it's whichever is the fastest route at that time. Now, a modem is a device that allows us to convert analog signals into digital and vice versa. So you might have heard of an analog to digital converter and a digital to analog converter, an ADC or a DAC, essentially like that for the internet, over a network, and this allows the signals to be transmitted over a phone wire. Now, back when I first had the internet, we had a little black modem next to the computer, but more often than not now, they're integrated into your wireless router. It's quite a seamless process for you to get onto the internet. Most of your devices are already connected, your router's on all the time, whereas when I first had the internet, which about, maybe ashamed to say, 22 years ago, we had to plug the modem in. It might be already plugged in, but you have to plug it in, turn it on, turn your computer on, and then because I had a dial-up connection, I had to wait probably a minute or two to connect to the internet whilst hearing all these funny noises, which sounds a little bit like this. And it used to terrify me when I was younger. I remember my dad doing it once and going onto the internet, and the computer at the time was on the room outside my bedroom, and that noise really freaked me out for a long time. But now it's quite nostalgic, I quite like it. But as I say, the router is now a part of your, the modem, sorry, is a part of your router now, 9 times out of 10. Now, servers. Now, servers are essentially computers with a piece of software running on them that allows clients to connect and consume services. Now, they're not technically a type of computer, or at least I say so anyway, as you could turn a laptop into a server if you really wanted to. However, you usually need specialist hardware to allow them to work more efficiently. So what I mean by that is, if I wanted to, I could host a website using a web server off my computer. My computer's just, I've got a Microsoft Surface, I could technically turn it into a web server. So as long as my computer's turned on and the server's running, people could view a website that was saved onto my computer. However, if you're wanting traffic 24/7 to your website and you want, like, maybe you've got a backup server and you want that running constantly, you need to have specialist hardware. So I had a server which just stored my files for me and hosted the website. I had a network attached storage, a NAS drive, which is like a special hard drive that is made for running on a network. It's made for being on all the time, and it's a little bit safer, because if you use a normal hard drive and that's on constantly reading and writing 24 hours a day, it's not going to last as long as a normal hard drive might on a normal computer. Now, web servers are devices that host websites. And what I mean by that is, all a web server is a piece of software with a folder on it that's called the website name, and then all your HTML files or your website files, they're all just on a folder somewhere. So when you visit a website, you download the HTML to that web page as well as anything else such as pictures, music, files. So when you send information to a web server, we call this uploading. Now if you want to add files to an external web server, you might use an FTP program or a file transfer protocol program. That's different from when you actually view a website, because you don't add to the website, you just send information to a web server and then you receive a response. And when you want to add your own files, say if it's your own website, you use an FTP program. Now when requesting data from a web server, your device is considered a client and the web server is the server. That's called client-server architecture. Now the more powerful the hardware that is powering the server, the more requests it can handle at the same time. Now, if you think about some games that have come out and said, oh, the servers are rubbish and people have been like slating these games, it's quite often that people didn't expect how many people were going to go onto the website or go onto the game, so they didn't have enough hardware or didn't have a strong enough computers. So that's sort of the reason what people are talking about. And there are also the types of server, and they all do different things. You have file servers, print servers, web servers, game servers, media servers. There's absolutely loads. Now, in networking, a packet is a small transmission that's part of lots of transmissions that form a message, usually around 65 kilobytes, they're not very big, and all internet traffic is split into packets before it's transmitted. Now, as it says, each packet is only a few bytes of information and contains information such as the sender address, the recipient's address, how big the message is, how many packets there are, a thing called a checksum, which we spoke about in an earlier video, so that's the thing that stops it corrupting, the data, and then it's got a thing at the end, like a footer that says this is the end of the packet. Now, the reason we have to have these is it's a little bit like a letter. When you send a letter, you're supposed to send who it's going to, the sender's address, and so the recipient's address. You also usually, when you send like a parcel or something, you put your own address on in case it can't make it. Then you put how big the message is. So if you go to a post office, you have to weigh a parcel so to get the price. So you need to say how big the message is, and then which number it is and the total number of packets. So if you've got 30 packets, you need to write, have I received packet number 1, packet number 2, packet number 3, and so on. And you need to know how many there are, because the receiving computer will keep asking for any packets that are missing. So if it doesn't know how many packets there are in total, it might be stuck in a loop constantly asking for packets when there's none left because it's finished. So that's why you need to know what the end of each packet is, and you need to know how many packets there are and which number that one is at that time. So going back to routers, what routers do is a thing called routing. So when you download a web page from a website, the following happens. So the HTML file is split up into packets into loads of little chunks. Each packet is sent out in order, so packet 1, packet 2, packet 3, packet 4. And at each router, and for each individual packet, the router decides the best or the most efficient or fastest route to forward the packet to, and then it sends it on to the correct port. Now, these packets can be sent loads of different routes, and they can all arrive in different times. So like I said, I could set off 5 minutes before somebody to go to the cinema, but when I go there I might get stuck in traffic and they might go the back route and beat me there. So your computer then rebuilds the HTML file by unpacking each packet and putting them again in the right order. Now here's an example where I'm sending a picture of My Little Pony. I've got a network of lots of routers. So first things first, I split up the packets and they all go down different routes and arrive at different times. The packets are then reassembled and the person at the other end gets the picture of Rainbow Dash. So you split up, they all took separate routes and arrived at different times and then got rebuilt. Now, Traceroute is a network tool that shows the route that packets take across a network. It allows us to see which servers our packet hops across when it travels to its destination. And it's also really, really useful if you know somebody who's not very good at computers and you show them Traceroute, it makes it look like you're a hacker of some sort, like you're a Mr. Robot or something. So it's quite good for convincing people of that. Now, I'm going to show you an example of Traceroute. Okay, so what I've got is just command prompt. So to open a command prompt, you can just type the Windows key and write CMD, and you command prompt up. Now, what you need to do is type trace RT, so Traceroute, and the website you want to track or the website you want to send the packet to. So I can go www.google.com, press enter. It says tracing route to for safe search at google.com, and it tells me their IP, which is 216.2.3.38.120, and then it goes through all of my various hops. So it took 2 milliseconds, 4 milliseconds, 6 milliseconds, and so on to go through. Now, when you get a star, as far as I'm aware, it means you've hit a firewall of some sort. So you've hit a firewall, so you can't go any further than that on that server. So then it keeps going, it keeps going, it keeps going. And you see the IP addresses have changed. It's gone from my IP address, it's gone to all these different IP addresses are the different hops, different routers along the way, until eventually it will get to that final destination that you want it to get to. So it shows how long it takes going from where I am right now, which is Vietnam currently, hence why I have my ISP is fpt.vn, so that's the person I pay for my internet, FPT. And then it goes from them, so it goes from my computer to the ISP, and the ISP to the internet, and the internet is right here, so it's going through all these different ones. So these are going to be various servers in various countries. Can't say those countries for certain, but usually if you Google a few of these IP addresses, you can usually find out where they actually are. So it's the trace complete, so I've got that there. So now if I just ignore my search for rainbow dash from my earlier example, if I look at some of these IP addresses, so if I go and type in 108.170, so 108.170, 0.233.3, it may give us a website. It might actually be Google itself, but I'll copy that as well. Let's see that loads. I'll go onto Google and I type in that IP address and go onto an IP address lookup like this. So it says this server is in Mountain View, California. It's IP version 4. It belongs to Google, and I can see that it's around here somewhere. If I take an earlier one, so 118.69, so 118.69, 0.184.86, it might be able to find it, it might not. So this one is in Ho Chi Minh City, where currently I am. So you see, I can see where my packets actually go. So it's gone from Ho Chi Minh City, where I am. That was that one there. So let's try 209.85. So 209.85. 0.148.242. So that one again is still in Mountain View. So you can sort of see whereabouts it's come from. So it's come from Vietnam through to America. And that's it really, that's Traceroute. So it's quite good for finding out IP addresses and just if you want a bit of an exploration of where you think. So I hope you enjoyed the video. I hope you learned lots about the internet servers and routing, and I hope to see you in the next video. I thought it was amazing. That's something for you to test out and have a bit of an experiment with.